Hi kids, hope you're doing all right. And today we'll be talking about composite shapes. Let's start with a quick recap. In last week's video, I talked about animation. So how setup typically sets up the screen size and the initial background color. And inside the draw block, which is called a function by the way, which we'll talk about later if we can, you have the rest of the code that acts like a flip book. So this draw code executes over and over and over again. We've also created here what's called a variable, and a variable holds a value, and we can keep changing the contents of that variable over time, which I've done on line number 13. So I initialize x to 550 because my display window width is 600. This is not the most efficient way, but it will do for now. I draw the circle with x coordinate as x, y coordinate always at height by 2, and after drawing the circle, I decrease the value of x by 2. So my circle will start from the right, from your perspective, and then go to the left. So when I run this, it starts from the right and goes to the left and keeps going on and on and on. Now what if I add another variable for y, which I initialize to 350, and I change x as well as y, and both are decreasing right now. So it will start from the bottom right and go towards the top, but it's not quite going all the way to the top left, which we'll talk about later. Now this is where precision is useful. So at school you might have done decimal numbers like 2.5, 10.5, etc. So wherever precision is required, we use float instead of int. Float means it can have a decimal point. Now you'll see that the entire display window is 600 pixels wide and 400 pixels high. Let's say I decrease x by 6 every time. It will take 100 steps to decrease by 600. Now what I want is, it should also take 100 steps to decrease by 400 because the height is 400. But if we decrease by 2, it will take 200 steps. So instead of that, we decrease by 4. Now when I run this, it will approximately give me the correct answer, which is good. But this is what we call hard coding. Because as soon as I change the size of my program, I will have to change those values as well. But this is out of scope for now. But I just wanted to show you that we can change multiple values as well, not just one value. Today what we'll do is we'll create a composite shape and then move that slowly. So let's create a box. Let's say this is the box that we want to draw. What we want to do is we want to have one point using which we draw every single thing. In this case, my front face is red, my top face is green, and my side face is blue for the rectangle, for the box. So I'm going to keep this point over here as my reference point. Why? Because for the rectangle, the top left corner is easy to keep as the reference point. Which means that, okay, I'm going to fill it with red. So this is my front face, red. I'm going to fill it with red and I'm going to draw, and you can see I've created variables x and y here. So I'm going to draw a rectangle at x and y whose width is 200 and height is 100. Then I'm going to draw the top face, which is green. So I'm going to fill it with 0 to 55, 0. And I'm going to use a new command called quad. Now quad is an extension of line which joins 2 points, triangle that joins 3 points, and quad will join 4 points, any 4 points. Now the good thing about this green quadrilateral is that I know this point is x comma y, And because the width of the rectangle is 200 pixels, I know that the top right point of the rectangle is x plus 200 and y. For the points at the very top, I can make some basic calculations. If this is x equals 200, then how far are we compared to 200? So if this is 200, if this distance is 200, what's this distance? And I'm gonna keep it as 50. So what it means is that it's further 50 pixels to the right. So it's x plus 200 plus 50. So x plus 250, and it's above, which means y minus 50. And then the top left point of the green quadrilateral, because we know that the length of the lines are the same, the bottom line and the top line, it is x plus 50, and y is the same as this point, so it's y minus 50. Similarly, for the side face, which is blue, I'm going to fill it with blue color and draw a quad. Again, the good thing is that we already know one point where the green and red meet, which is x plus 200 and y. And then the bottom point, because it's right below that first point, is the same x, but y is 100 more than that because the height of my front face is 100. Then the same logic will be used to create the other 2 points, x plus 250, because it's 50 to the right, y plus only 50, because you can see that it's somewhere in the middle, and not somewhere in the middle, exactly in the middle of the top and the bottom red face. And then the top most point where the green meets the blue is the same x, and y is y, which is here, minus 50. Okay, so we run this, and there you go, that's our box. The good thing about having just one reference point, which is xy, so let me just do one more thing. Draw the reference point. I'm going to draw the reference point at the very end. So fill with 0, 0, 0, which is black, and draw a circle at xy with diameter 10 only. So my reference point is visible. And 20. So that's my reference point always. So when we want to move the box, we don't have to move every single face individually. All we have to do is increase x. So x becomes x plus 1. Let's just start with simple x increases by 1. So everything moves because everything is in relation with x. We can also decrease y. Y is y minus 1. There you go. Now, because I want precision, I'm going to make these x and y as float. And instead of moving them by 1 every time, I'm going to move them with a random value which is between -1 and 1. We did random numbers last week. So random -1, 1 will be replaced by any random value between -1 and 1. So it can be -0.5, it can be 0.75, it can be 0, it can be 0.6, it can be 0.2, and so on and so forth. So when I run this, my circle, my box is moving with a random value. Of course, if I increase it by a higher scale, you will see that it moves even more. Instead of randomizing it, you can predetermine speed at which they should change. So again, I'm going to create 2 more variables for this. Speed x is a random value between -5 and 5. Speed y is a random value between -5 and 5 as well. And initially x and y, we don't know what x and y will be. So this is the next step up. After we declare size, we know that the variable width contains the value 600 and height contains the value 400. So now we can say x is half the width and y is half the height. So my box reference point will be in the middle of the screen. So we run this and you can see that every time the box moves correctly, we don't know where it's going to go, but it goes correctly and slowly. So this is how you move a composite shape. What are the lessons? Let's write those lessons at the very top. Number 1, keep a single reference point, usually x and y, for the entire shape. Draw everything in relation with the reference point. And 3, update reference point as required. So what I would like you to do is practice task, and of course this task is not mandatory, but if you enjoy programming, then it's only in your interest to do these. You can draw a matchstick figure and move it as you see fit. You can draw a flower and move it around. And third one is you can draw a car or an automobile and move it. Next week I'll be back, so I'll come to the school and we'll talk about conditions, which is very interesting. Let's see. Thank you.